Hello and welcome to the first of 4 videos going over the midterm geometry review. This is going to be a little while, so I'm going to go ahead and get started on this. On our very first question it says list all undefined terms. So there's 3 undefined terms in geometry. Those terms are point, line, and plane. Be familiar with these terms because this is going to be a very easy question that is on the test that you might not want to miss. Alright, for our next question it says find QR in simplest radical form. So what it's actually asking for is what is the distance between the points Q and the point R. Alright, so we have a couple options on here. Originally, because we have these ones, you are really intended on wanting to do not Pythagorean theorem, the distance formula. So you actually get the ordered pairs. So for example, R here is at -3, +3, and then Q is at +3, -3. So we would use the distance formula, which again is D equals to the square root of x2 minus x1 squared plus y2 minus y1 squared. Now, again, you can use that formula and it won't work or won't have any issues on doing this. However, because we actually have a graph, there is an easier way to do this one. The better way of doing it with the graph is we just basically make ourselves a right triangle. Once we have a right triangle, if we know 2 side lengths, we can do Pythagorean theorem to find it. Whenever I make this right triangle here, this angle here and the bottom is 90, we can just count how long this line is. So the line here that I am now kind of double highlighting here, we count up, there is a total of 6 spaces. Count the bottom line, we also get 6 spaces. So we now have a right triangle that has the legs 6 and 6. Okay, so Pythagorean theorem would say a squared plus b squared equals c squared. A and b are the legs, so we're going to do 6 squared plus 6 squared equals x squared. Okay, 6 squared is 36 plus 36 equals x squared. Alright, 36 and 36 is 72. But we don't want x squared, so we have to divide by, or not divide, take the square root. Alright, square root of 72 gives us a value. If we plug this in the calculator, we would get 8.5 about. But simplest radical form is not a decimal form. You're going to have something underneath the square root. So again, on the multiple choice test, you can just plug in all your answers and get the values. Now what is intended on this is we take 72 and do a factor tree. So 72, for example, would be 2 and 36. 2 can't break down anymore, so we break down 36, 6 and 6. Now I could continue breaking down here, but notice I already have a pair. Anytime you have a pair, you take the number out and you leave everything else inside. So simplest radical form for this one would give me 6 square root 2. Now again, you don't necessarily have to be able to do that because on multiple choice you can plug in and see which one it is. Now if you have the option of square root of 72 and 6 square root 2, they would both give you the same answer, but the idea on this is you should be able to realize which of those is actually simplest radical form. Alright, so problem 3 says P is the midpoint of CO, and it has P located at -312 and O located at 7,4, and wants to find the value of C. So for this one, you could use midpoint formula. Again, an easier method on this would be setting up a kind of a logical method on this. We know that the midpoint is between the 2 endpoints, so if I set this up, say endpoint, midpoint, endpoint, I'm just going to start labeling things and figure out how one goes to another and then logically just conclude the next part. So P is the midpoint. So I'm going to put this -3, 12 in the middle. And then the other part is an endpoint. If you're given an endpoint and midpoint, my suggestion is to put the endpoint on the top, 7, 4. And then you work your way down. So how do you go from 7 to -3? Well, you subtract 10. So you just continue that same method. Negative 3 minus 10 gives us negative 13. Do the same thing for the y's. So 4 to 12 is plus 8. Plus 8 again gives you 20. So that gives you your endpoint as negative 13 and 20. Now, for problem number 4, it says plane FUN and plane NAF intersect at what figure? So whenever two planes intersect, there's only one type of figure that they would intersect at, and that is a line. So we would have this as a line, definitely. So key on this one is make sure that you're looking for a line. Now, in order to name a line, you have to have two letters that you know are on that line. So we need to figure out two letters that we know are on both of these planes. So if I look at it, I have F and N, and then I have N and F. So both of those ones are evident in both planes. So I know that we have this as being like line FN as a possibility. Again, don't get confused. Do not say it would be ray FN. Do not say it would be segment FN. You want to make sure whenever you're doing this, it's the line with the lines on it. Alright, so number 5, it wants you to write the inverse of the following statement and then determine if it's true or false. Okay, so we need to first figure out what inverse would end up being. So with the inverse, alright, there's 4 different ways, technically 5 if you want to talk about it. The original way is the conditional. So again, the conditional is the original way. Now, the converse is whenever you switch the order. So the first part goes to the end goes to the last part. The inverse is where you change both the first and the last to their opposite meaning. And then the contrapositive is where you do both switching and the opposites. So since this is the inverse, we're going to change both of these ones to not. So the original statement says if the diagonals of the parallelogram are congruent, then the parallelogram is a rectangle. So what we would really do is change this to not, and then this side to not. So the new statement would be read something as, if the diagonals of a parallelogram are not congruent, then the parallelogram is not a rectangle. So again, when you pick whichever answer matches that one up, we need to figure out if it's true or false. Right? The likelihood is this question or this statement will probably be there twice, and you just have to figure out which one's the right one. So properties of a parallelogram, and particularly a rectangle, is on a rectangle your diagonals are congruent. So if you have diagonals like here, again, you can't really mark the entire way, but these all 4 are the same, because property of the parallelogram itself is the diagonals bisect each other. If they're bisected each other and they're congruent, then all 4 parts have to be congruent. But anyway, so we need to find a diagonal or the parallelogram with diagonals that are not congruent that would be a rectangle, which is impossible. So therefore this statement that we have is true. And if you can't disprove it, you're going to say it's true. Alright, so the next one, it says draw a conclusion from the given information. Given 2 lines are perpendicular if they form right angles. If 2 lines meet at a 90-degree angle, then they are perpendicular. And then it says 2 lines meet at a 90-degree angle. So this is a kind of a combination of law of syllogism and law of detachment, where you're basically taking parts of these ones and getting a statement from it. So what you actually want to notice on this is that the first part of the first sentence is the last part of the second one. So if on any of these ones where the end of one is the same as the beginning of it, you can kind of cut out that middleman and just go with if the first one, then the second. So for this case, I could just basically be saying that if 2 lines meet at a 90-degree angle, then they form right angles. Okay, so that is one of the parts of it, but it gives this extra information here saying that the 2 lines meet at a 90-degree angle. So that 2 lines meeting at a 90-degree angle satisfies the hypothesis of our new statement. If it satisfies the hypothesis, then you can say that the conclusion is true. Therefore, we would end up saying the two lines form right angles. So it's, again, basically you're satisfying the hypothesis, you get the conclusion. Alright, for number 7, it says name an angle adjacent to AOB. So first thing off, we need to identify AOB. So we're going to do this. Here's A, goes to O, goes up to B. So here's angle AOB. Adjacent means something next to. So basically we want to have an angle that is touching one of these two rays. So we basically just have to pick one of those. So there's a lot of options on here. As long as it basically has BO or AO as one of the sides, then you can say it. So like I could do this as BOC. BOC would be a possible answer. Alright, I could have done angle BOD. I could have done AOE. Again, basically I need to get an angle that ends up working through it. But again, you're just going to look at this. You have answer choices that you're going to be picking from. Just pick whichever one's closest to it. Alright, so on the next problem, it's a proof. But again, on this one, you're not actually writing proofs. You're just kind of filling in the blanks and figuring out what should be going in the spots. So you're going to have answer choices that you can choose from. You should be able to figure out, based off like pretty much a word bank, what the answers are. So anyway, on this first one, it gives us, it starts off with what we're given, so the reasons given. Next one was going to say that E at G, so EG, the entire line here, is the same as EF plus FG. So basically we got a part plus a part equals the entire thing. Okay, so that's should pop up in your head automatically that should be segment addition postulate. You have two segments that you're adding together to equal the entire thing. It's segment addition postulate. Now for the next part, what they're doing is the same thing, but they're using the other side, right? But when we move to step 4, if you notice on here, we're taking the original statement, EG is equal to FH, and they had EG equal to EF plus EF plus, or yeah, EG equal to EF plus FG. Okay. Then the other part, they have FH equal to FG plus GC. So what happens here is that the FH gets replaced with FG plus GH, and the EG gets replaced with EF plus FG. So we're basically just putting these parts in together. So again, it kind of can be interpreted two different ways. This would really be transitive property, but you could also make the case that it's substitution. So either one of those, again, basically either of those ones is meaning that you are replacing a portion of the actual problem. So for this case, yeah, we'll go with either of them. So I will say transitive R is substitution. Again, look at your answer choices and see which one actually works best. On number 9, we are doing a reflection over the y-axis. So the rule for this that you want to remember is whichever axis you're flipping over, that value stays the same, the other one becomes the opposite. So in this case, the 1 here would stay the same, the -7 becomes +7. So that would be your answer. Now, if you don't remember the rule, there's another alternative to it. You could just draw an XY axis. So after you've drawn an XY axis, you can just plot the point. So it's left 7, up 1. So it would be somewhere around here. So -7, 1. If I'm reflecting over the Y axis again, Y is up and down, X is left and right. It would flip in this direction. So that would make it over into this spot, which would then be +7, 1. So again, if you don't remember the properties, you can easily just draw a picture and get a result. Now, with that being said, we are actually going to have to do that same thing for the next one. It's the easiest way. Again, you could remember the properties, but it's a lot easier to instead just graph an XY axis and figure out your result. So on this one it says, which mapping represents the rotation of 270 degrees clockwise about the origin? So I'm going to draw an XY axis. Again, it does not have to be pretty. I'm going to do 2 points that are fairly unique to each other. So I like to using the numbers like 1, 4. So I can easily tell the difference between those two whenever I'm doing a rotation. So like this would be 1, 4 here. Okay. If I'm rotating 270 degrees clockwise, I'm going to, actually the easiest way, take my paper and turn it once, twice, 3/4 turns to the right. Again, if it was counterclockwise, you turn it to the left. Again, if it doesn't specify which way, you gotta go counterclockwise. Okay, but you want to really just focus on doing that. So when I do this, it's once, twice, 3 times. The point moves into this quadrant, but it's no longer in like the same spot. It actually goes left 4 and then up 1, so that becomes -4, +1. So how does this translate to what I'm actually doing here? So if I'm actually looking at these results, my original x was 1, my original y was 4, right? So that's what I have for the very first part. That's what the values that we have on the left. How do those numbers change? Well, look at the 1. The 1 is no longer in the front, the 1's in the back, so I put the x in the back. Now it's still a +1, so it did not change the sign of it. There we go. On the front though, that 4 that was in the back moves there, so the y is now in the front. However, the sign's now negative. So with it being negative, we put the negative in front of the y. Notice we have the exact result that we need, and therefore our answer is C. Alright, continuing on with this, number 11 task, how many lines of symmetry does this figure have? So looking at this, there's a little bit of a stretch out with it. It's not exactly the same, but we could still fold it down the middle, hot dog style, and it be the same on both sides. So there's one. Then we could also fold it hamburger style down this way, and that's the same. So those two actually would fold over on itself, giving you 2 lines of symmetry. Now you might ask yourself, why doesn't like the diagonals work this direction? And the reason why that one does not work is because if I actually folded this over the line going this direction, this line would actually continue off this way, and it wouldn't work out the same. So we can't do it that direction. Therefore, when we're actually doing this, you're actually only limited to these 2. Alright, the final question on this video is going to be decide whether the figure has line symmetry or rotational symmetry. Define the number of lines of symmetry and or the rotations that map the figure onto itself. So first we're going to check to see if there's line symmetry. This is an oval. So if I actually drew a line this way, does it reflect over itself? Yeah. So that's at least one, but there's actually another one where it's going this direction. There's actually 2 lines of symmetry. Now, for as far as rotational symmetry goes, rotational symmetry is if you can rotate it around the center and it look the same without going completely 360 degrees around. Okay, so rotation, right, if we're looking at this, if I start off at this point here and I turn it all the way to this side, does that remain the same shape? Yeah. So I could do it back again. Notice that basically I repeat myself twice. Okay, so it repeats with an order of 2, but if we're talking about angle, we're going to do 360 divided by the order, and that gives us our actual result. So 360 divided by 2 gives us 180. So our rotational symmetry is 180 degrees.